Warm up for lesson 4-6, quadratic formula and the discriminant. Pause. Pause. Lesson 4-6, the quadratic formula and the discriminant. Here is the quadratic formula. The formula is based on the coefficients of the quadratic, so it's dependent on this number, and this number. And here is the quadratic formula. So in this example, A is equal to 1, B is equal to 5, C is equal to 6. So we put these numbers into the formula like this, and then simplify. Let's take a look at an example. Now, this problem right here is not ready for you to use the quadratic formula. You must bring the 11 to the other side. And so now A is equal to 1, B is equal to -10, and C is equal to -11. We're going to follow the formula right now. So this is X is equal to, don't say negative B, say opposite of B. So we want the opposite of -10, which is +10, plus or minus. And we want to square 10. -10, when you square a negative number, that's going to be a positive number. When you square a negative number, that will be a positive number, -4. And then A and C, I'm just going to multiply that in my head, -11, all over 2 times A, which is 2. So this is going to be equal to 10 plus or minus root. Now this is 100. And then this is 44, +44, so this is 144, which is a perfect square. So we're going to say 10 plus or minus 12 over 2. So we can say 10 plus 12 over 2, or we can say 10 minus 12 over 2. This becomes 22 divided by 2, so X is equal to 11. Or this is -2 divided by 2, which is -1. These are the solutions to this. If we were to put these numbers into here, they would tell the truth. Okay, let's pause and see if you can use the quadratic formula. Remember that you should bring the 30 to the other side before you start doing that. And here are the answers. Again, I've moved the 30 to the other side. I identified my A, my B, my C. And I went ahead and put it in here, and I simplified here. That was a perfect square, which was 17, and I just went ahead and used the minus and the plus to figure out the two answers. All right, we're going to solve each using the quadratic formula. I'm going to show it again one more time. X squared plus 6x minus 16 is equal to 0. Identify your A, your B, and your C. A is equal to 1. B is equal to 6, C is equal to -16. So my X is going to be equal to the opposite of B, plus or minus, I'm going to do B squared in my head, which is 36, minus 4 times A times C, all over 2 times A. -6 plus or minus. Now this portion right here is going to be 64. And that's going to be a +64, and +64 and 36 is going to be root 100. So this is going to be -6 plus or minus 10 divided by 2. If I use a positive, that's going to be -6 plus 10, which is +4 divided by 2 is 2. Now I'm going to use -6 take away 10, which is -16 divided by 2, which is -8. Okay, over here, everything is on one side, so I can identify my A, my B is 25, and my C is 33. So my X is equal to opposite of B, plus or minus, now B squared I know is 625, minus 4A and C, all over 2A, which is going to be a 4. 2 times 2 is 4. So this is -25 plus or minus root, and now I'm going to figure out what 625 take away that product is, and that answer is 361 over 4. Now if you take the square root of 361, you are going to get plus or minus 19 all over 4. So when I do negative 25 plus 19 over 4, that'll be one answer, or negative 25 minus 19 over 4. Now this is going to be a negative 6 over 4, which is negative 3 halves, or now this is going to be a negative 14, and divided by 4, that'll be negative 11. Alright, now in this particular problem, when you use the quadratic formula, you're going to find that under the square root is going to be a 0. So you're going to add or subtract 0. And what ends up happening is you only really get one answer. And the reason that's happening is the parabola is just really hitting the x-axis at one point. Okay, let's take a look at some examples. And in all these examples, the thing under the square root ended up being 0. So I ended up only getting an answer. If you were to graph the parabola here, you would find it was just intersecting the x-axis at one point. Okay, pause to see what you can do. And here's the answer. Now another thing that the parabola could do is the parabola could hit it twice, but the answers will not be rational. They'll be irrational, because what's under the square root you will not be able to have a perfect square. So you'll have some kind of square root expression. And so it looks a little bit more complicated, and if we were to put it in the calculator, we would have to round to give us a decimal. So when, again, sometimes you get answers with a square root in them. Okay, let's take a look at these problems. When I identify my A and my B and my C, I found out when I worked under the square root, I got a 13. There was nothing I could do with a 13. So the answer was negative 5 plus root 13 over 6, negative 5 minus root 13 over 6. When I did 3B, again, when I simplified, I got square root of 28, which I could simplify to 2 root 7. That's about the best I could do. So I still have a root answer. I'm going to divide 2 into both of those expressions. So that's 4 plus root 7. And here are the two answers that I have. Pause and see what you can do. And here's the answer. All right, let's take a look at this, solving this quadratic. If you were to put in the calculator, you would see that it does not hit the x-axis at all. And here's, I identify my A, my B, and my C. When I put them in, I'm going to get a negative under the square root. Negative under the square root means I'm going to have a complex root. I'm going to simplify that to 2i. And so my roots, or my solutions, are complex numbers. They're not real numbers. The calculator won't show them, but we know that they're there. All right, and here I have started the problem. I haven't quite finished, and I'm going to finish with you right here. Negative 5 plus or minus, and I know this is going to be root negative 1 times root 23. So I'm going to say I root 23 all over 6. So one of my answers is negative 5 plus I root 23 over 6, or negative 5 minus I root 23 over 6. Those are the two answers. Over here I've done it and I have a negative under my square root. So this is going to be a 6i. Remember, this is root negative 1 times 36, and I'm taking the square root of each one of these. All over 2. Divide each of these terms by 2. 2 plus or minus 3i. So my two answers are 2 plus 3i or 2 minus 3i. And those are my two complex solutions. Pause, see what you can do. And here are the answers. All right, let's take a look at the discriminant, because the discriminant can kind of tell us what the parabola will be doing. And the discriminant is this part under the square root. Remember, this could be a perfect square, which gives us rational roots. This could be 0, which will only give us one root. This could be a number that you can't simplify. You'll have a square root, so that'll give us two irrational roots. And then this could be a negative number, and that'll give us two complex roots. So looking at the discriminant is very important. Okay, so let's talk about it one more time. When the square root is a perfect square, then we're going to get rational roots. In other words, they're going to be in the rational system. They could be fractions, they could be whole numbers. If this number here is not a perfect square, then that means you're going to have a square root as part of your answer, and that's irrational roots. If what's under the square root is 0, that means you're not going to add or subtract anything, and you're just going to get one rational root, because you're going to get something that could either be a fraction, an integer, or so on. Now, if this part under the square root is a negative number, then you're going to get two complex roots, which means it never hit the x-axis at all. All right, let's take a look at seeing if we can discover what's happening here. I identify A, B, and C, put it in the discriminant, and that's negative. Negative means you can tell me it's two complex roots. I identify our A, B, and C. We're going to find we get 0 when it's 0, when, remember, that's one rational root. Okay, let's take a look at these problems. I've identified the A, the B, and the C. The B is going to be 64 minus 4AC. Now this is going to be 64, and this is going to be negative 20. Now this is going to be a 44. Now this is not a perfect square, so what we say, this is going to be two irrational roots. Okay, over here, b squared is going to be 49 minus 4ac, and this is going to be 49 plus, and then this is going to be 240. That adds up to 289. 289 is actually equal to 17 squared, which means it's a perfect square. Well, if it's a perfect square, then that means I'm not going to have a square root, and we'll have two rational roots. Okay, pause to do the problem, and here's the answer. So in summary, with all the methods that we've been looking at, graphing will sometimes use only if an exact answer is not required. So you can use graphing and let the calculator estimate the answers. Factoring, if the factors are easy to determine, you're going to want to try to solve it only with that. Square root property is if you take the square root of both sides, if you have a perfect square on one side. We did not do completing the square, but we did go to the quadratic formula, and the quadratic formula always works. Always works. It's tedious, but if we have tried other things and they don't work, then that'll always work.